This lesson is all about the chemical reactions of ethanol. And as you can see here, this is a molecular model of ethanol. So I'll just draw up ethanol to remind you. And in the diagram, you can see the black parts are the carbon atoms, and the white parts are the hydrogen atoms, and the red part there is the oxygen atom of the hydroxyl group of ethanol. So the reactions I'll be talking about today are the dehydration of ethanol to ethene, and also the hydration of ethene back to ethanol. And I'll also finish up by talking about the oxidation of ethanol. So let's start by looking at dehydrating ethanol. And if you think when you're dehydrated, you've lost a lot of water, and that's exactly what's happening here. So from this diagram, you can see that ethanol is losing its hydroxyl group and another hydrogen group to form water, and it's turning into ethene or ethylene, which we spoke about previously. So it involves the removal of a water molecule from ethanol to make ethylene. In the reaction, we use concentrated sulfuric acid, which acts as a catalyst, but is also a dehydrating agent. So it actually takes up the water that's given off from the ethanol molecule. So here's the reaction for the dehydration of ethanol. So we start with liquid ethanol, and in the reaction, if we want to go forward, we use concentrated sulfuric acid, H2SO4, and what we get is ethene, gas, and water as a liquid. So H2SO4 is a catalyst. Acting as a catalyst will speed the reaction up so that we get the product ethene. H2SO4 or sulfuric acid is also a dehydrating agent. So it will remove water as it's formed, so shifting the equilibrium to the right. If you can see here, there's actually an arrow going the other way. So this reaction can go both forwards and backwards. So in a moment, I'll show you how we can go from ethene back to ethanol. And this is quite common in organic chemistry. You can go forward in a reaction, and you can also go backwards, depending on the reagents and the conditions that you use. So before ethene was readily available through catalytic cracking of petroleum, it was mainly produced from ethanol. Now, as I said, this reaction is reversible, and this reaction is the opposite of acid-catalyzed hydration of ethene to form ethanol. By using carefully controlled conditions, it's possible to favour the formation of either reactants or products. So looking at the production of ethanol, now it's made from the fermentation of various grains and fruits from the past 5,000 years. So if you think about ancient times, they tried fermenting fruits and grains, and they came up with alcohol. And they came up with ethanol. They didn't know what it was back then, but if they left fruit rotting, they came out with ethanol, and they'd have quite a fun time. So this process continues to be used today, but it's not the major source of industrial ethanol. So fermentation of such things as grapes to form wine, or potatoes to form vodka, or hops and malt and yeast to form beer, is continued to be done to form those alcoholic beverages, but not for an industrial source. We just can't get enough ethanol out of that particular method. So in industry, the principal method of production involves the hydration of ethene formed by the petrochemical industry. So if you recall in previous tutorials, we mine the petrol, we make the ethene, and then if we hydrate ethene, we can get ethanol for industrial uses. So let's look at the hydration of ethene or ethylene. It's the exact opposite of the dehydration of alcohol or ethanol. So if you see, if we put water onto ethene, we get ethanol. So in a large factory plant, they would run through steam through ethene, and various conditions, it's acid catalyzed, you will get ethanol there. So we use diluted sulfuric acid or phosphoric acid as the catalyst. And here's the equation for that. So it's just the opposite of the equation we had before, where we were going from here, ethanol, to there, ethene. This time with hydration, we're going from ethene and water this way. Okay, so it's a neat little reaction that's going on. And the conditions, diluted sulfuric acid. So a few more conditions that they used for this process. The reaction pressure is 60 atmospheric units, ATM. The temperature is 330 degrees. And this is an example of an addition reaction. So just keep that in mind. In organic chemistry, it's an addition reaction because you're breaking the double bond and you're putting something on to an alkene. So our last reaction that I'd like to talk about is oxidation of ethanol. And as you can see here, you have an alcoholic beverage on fire. So you probably already are aware that ethanol is flammable, okay? And the first type of oxidation is actually combustion. So where you have ethanol and oxygen, and if you have an ignition source, it goes to carbon dioxide and water. And there are two other types of oxidation. I'll just talk about this one first. It will burn with air to produce carbon dioxide and water. Okay, ethanol can also oxidize to form two new species called ethanal or ethanoic acid. So the reason that they have those different suffixes on the words is because they have different functional groups, and they're called alkanals or alkanoic acids. So let's look first at oxidation of ethanol to ethanal. So if we start with ethanol, if we oxidize it, we get something called ethanal, and we get hydrogen ions and we get extra electrons. We use potassium dichromate, which is this compound here, as the oxidizing agent. So let's look at ethanal for a moment. If we draw that, just so you can see, CH3, C, H, and then an O. So the alkanal group is a double bond to an oxygen. And the reaction proceeds at a much slower rate than combustion. And the Al, as I showed you with that little diagram, the Al suffix refers to a terminal double bond to an oxygen atom. Okay, so that's, if ever you see Al at the end of an organic compound, always think an alkyl group with a double bond O at the end. So that's a new functional group for you to learn and remember. Similarly, another one to remember is ethanoic acid, another type of functional group. Ethanoic acid is an alkanoic acid. Okay, that's the functional group. So ethanol with water goes to ethanoic acid, COOH. So the ending here is going to be C, double bond O, OH. And that's an ethanoic acid. CH3, there we go. That's our functional group, oic acid. And you get some protons and you get some electrons coming off as well. So just rub that out of the way. And in the body, ethanol, if humans drink, or animals even, drink ethanol, it's metabolized to produce ethanal and ethanoic acid, and it's eventually oxidized completely to carbon dioxide and water. Because these reactions are strongly exothermic, which means heat is given off, ethanol is a highly calorific food. Not that you could call it a food, but if you think about it, when they talk about if people drink, they put on weight. And the reason for that is, it's not so much for what you're drinking it with, it's actually the alcohol is calorific. It will, because it's exothermic, take you longer to actually digest, and you'll actually put on weight from drinking alcohol. So that's where that comes from, because of that reaction. Now, finally, breathalysers. Now, they're used by police to determine blood alcohol levels, and they actually measure the concentration of alcohol on a person's breath. Some breathalysers are based on the reaction of ethanol with the dichromate ion, which I showed you just before. And the extent of colour change, so what happens in their breathalyser is there's a colour change. and they'll get a reading, so it's digital, but the extent of the colour change will go from orange, which is the dichromate ion there, to green, which is just a chromium ion, Cr3+, and that's used as a measure of alcohol concentration. So that sums up our reactions of ethanol. So we'll look at some questions now. Question 6. Identify the product formed by the dehydration of ethanol. So let's look at the equation to start with. Ethanol with concentrated sulfuric acid going this way, because it's dehydration, we're getting ethene, gas, and water. So our answer is ethylene or ethene. And if you remember, ethylene and ethene are the same thing. They're interchangeable words. Question 7. Identify a catalyst used for the dehydration of ethanol. So we're looking for a catalyst now. Same reaction again. Okay, ethanol to ethene and water. What's the catalyst? It's concentrated sulfuric acid. So concentrated sulfuric acid is our answer to question 7. Question 8. Name the process that involves the addition of water to ethylene in order to manufacture ethanol. Okay, so water and ethylene to manufacture ethanol. What's that process called? Okay, the addition of a water molecule to the ethylene structure will produce an ethanol molecule. The addition of a water molecule is called hydration. So when you think hydration, always think addition of water. Okay, so that's our answer is B. Question 9. Draw the structural equation for the hydration of ethylene to ethanol. So let's start. Ethylene, there's our structure. We draw that, double bond. We draw water, H2O. Now looking here, always draw, when you're drawing a structural equation, always try and draw water in this way, because there's a very specific angle of water in here. It's around about 72 degrees, I think. Don't quote me, but that angle is very, very important for the bonding and the properties of water. So it's always good to draw H2O in that way. So with diluted sulfuric acid, we get ethanol. So that's your structural formulae. Question 10, finally. What other functions besides a catalyst does sulfuric acid have in the conversion of ethanol to ethylene? Now remember, there were two different functions, one of which is a catalyst, the other one. Okay, so let's look at the fact that the conversion of ethanol is called dehydration. Concentrated sulfuric acid is also the dehydrating agent. So not only is it a catalyst in this process, but it's also a dehydrating agent. So it removes the water molecules from the system as it forms, which shifts the equilibrium to the right to promote the dehydration process so that we get more ethene. So that's it for our topic today, and in the next lesson I'll be discussing fermentation.